Hello everybody, welcome back. So when we last left off, we were working on the Breakout game, and we got to a point where we had just a little bit of a bug, where when we bounce off the table, it's not quite bouncing exactly how we want it. So I decided that probably what I'm doing is overcomplicating things just a little bit, because all we want to do is create something just very simple to be a game. And the idea behind it is that we have this platform that we're moving back and forth, and what we want to do is control whether we want the user to be able to control how much or kind of steer the ball, right? So we either want to add or subtract to the dx of the ball, the x velocity of the ball. And so what we want to do is, say it hits on one side, we actually want it to kind of go to the other, right? So if it hits on one side, we go to the opposite, and that allows us to have this kind of a stable control over the ball. If we hit it in the exact center, the ball will have a perfect reflection off of the system. So let's go ahead and do that. What we'll do is we'll handle this collision with the platform, and we'll just go ahead and start by deleting that current code. And all we want to do is, I'm actually just going to write out some of the things that we want to do here. So we'll do the bounce the ball, and then we'll want to add or get distance from center of or calculate the distance from center of platform. Add factor, add dx factor. And then that's about all that we need. So those are kind of the major things that we want to accomplish. So bouncing the ball is very easy. So we'll just say that b dy equals -1 times b dy. So that's very good. And then actually, oh wait, there was some other thing that we wanted to do. Oh, we want to make sure that b position y is, I believe, the same as the scene player position y, and then we'll add half of the height of the player. So that allows us to make sure that when the ball bounces, it bounces off of the top of the platform. So now we want to calculate the distance from the center of the platform, and for that we'll say player center x, and it will be the scene player position x plus half of the player size, which is 120, so we'll go 60, and then we'll have the ball center x, which is going to be ball position x plus 5. All right, so now we've got the center of the player and the center of the ball, and now we need to essentially get the distance from the center of the player. So what we're going to do is we'll get distance, and we're going to start with, we're going to actually have the player, I believe, player minus the ball. Yes, we'll do player minus the ball. And the reason for that is, let's say here is the center of the player and the ball is over here. Then what we want to do is go to the opposite direction. So if the ball is further to the left of, actually from your perspective, if the ball is further to the left of the thing, we actually want to have a negative value. So we'll say player center x minus ball center x, and that gives us a distance in pixels between the two. Now, what we'll do is we'll have some kind of dx factor that we want to change the distance by, and so that will be the distance divided by, let's say, the how much should it be? It should maybe be by the, let's say, the size of the so the dx factor is the ratio of the distance to the width of the player. Okay, so then we just add that factor in to our ball. So ball dx plus equals dx, and that should give us what we need. Now, in order to test this, what we'll do is we'll set our dx to 0. So that way we're dropping straight down, and then we can test by moving our platform over and seeing if we're getting the right direction that we want out of this. And we may want to fine tune how much we want to do this. So we'll middle clip for build. Oh yeah, log, I'm not using this anymore. So we'll close that, and then do a put build. Let's run a breakout session. Oh, there we go. Okay, good. So let's see, will it go more towards the left? That's good. Or to the right. Okay, that seems to be good. So now the only thing that seems to be a little bit wrong here is the Y position is not quite correct. So we need to fix this part here. So when we do this collision, +5, probably -5 here. It's probably what we want to do instead. So let's do a go build. Let's run a breakout, see if this works. Oh yeah, that's much better. And let's see if we can go to the other side, right? Can we get it to move to the other side? Boom. Aha, yes. So it's going to the opposite direction of the side that it's on, which is good. So it's actually doing exactly what we want. Now, we may actually want to give it a little bit even more control than what it has. So what we'll do is instead of 120, we'll make it 2 times more powerful. We'll put it at 60. And we'll build this. We'll go breakout. And boom. That seems pretty good to me. So that'll give us some control. Now, the other thing that we probably want to do is to make this game interesting. We'll actually have, we'll increase the Y speed. So every time we bounce, we just get a little bit faster in the Y direction. So that way, the ball will eventually be going very fast. So increase speed along Y direction. So we'll say B dy. We'll increase it by 0.1, just a little bit. So each time we'll get 1/100th of a, well, maybe not 100th of a pixel. Maybe we should say 5/100ths faster. And so just very slowly, this ball will actually get faster as we go along. And we probably should do it even more, right? But there we go. Boom. So now what we can do is we can return our original speed here. So we can say we had 5 here. Let's bring it to 4. And so now our system will be a little bit faster than it was before, and we can have a more interesting game. So now the speed of the ball should actually be getting faster along the Y direction after every single bounce. Now, in order for us to detect this, we could print it out, or we could just make the bounce delta so big that it becomes obvious what's happening. So let's go ahead and do that. Let's create this delta, this bounce delta, and let's make it a lot bigger. So it'll be 1/5 of a pixel. So every bounce, it gets a 1/5 of a pixel faster. And hopefully that will make it obvious that the system is actually getting faster every single bounce. Or maybe that's still too much, because it would take 5 bounces to be 1 pixel faster per frame. So let's go ahead and make it even faster, right? So let's make it 3. Now it should be very obvious. So we'll do a build, break, boom. Oh, whoops. are we actually... that's right. Because look at this. Okay, let's see what happens here. Let's see what happens. Boop. Okay. So that's because our ball position... That's interesting because the ball position... Oh, we're adding 3. The ball should be going up, right? So this is how you can catch some of these things. So we caught a little bug. And now it should be going much faster. Boom. Boom. And eventually it'll just get so fast we can't deal with it anymore. Oh, there we go. So now that's pretty good. So let's have it be a little bit more reasonable. Let's have it at say a 0.5. So that way it gains 1 every 2 bounces, and this will give the user a little more time to actually clear out all of the bricks. Now, the other thing that we probably want to do is, let's see, what should we do here? So now the user can control the direction, they can control the size. The next thing that we want to do is essentially have the person, we need to have a win and a lose condition. Now, I think we probably have spent enough time. Well, let's see. Yeah, I think we've probably spent enough time for a single video, so we'll go ahead and do winning and losing in the next video. And the idea behind that is we'll have maybe some kind of score that we're keeping. Well, let's see. We could keep some kind of score, or we could also control how the... well, obviously, if you go out of bounds, like we could have lives, and basically every time you go out of bounds, you lose a life, and it restarts the ball, but you still have the same thing. So we'll have to see what we want to do for that. But in the meantime, it's actually pretty good. So till next time.